This is a 3D printed RC tractor, which I've spent the last 3 months iterating to build something that not only has 4-wheel drive, letting you climb up any grade you like or over any obstacle you want, but also a high-low transmission so that when you're done digging yourself out of this pit, you can shift it into high automatically via a servo and zip away at high speed. But when you need extra power to, say, pull this ripper, just drop it back into low for more grunt. This tractor has a 3-point attachment system, letting you quickly and easily swap between attachments, as well as hook up to a PTO driven attachment like this blade, which can be tilted on the fly depending on what you need. Everything from the tires to the gears is 3D printed, meaning if you drive it off your table and break it, just 3D print some new parts, fix it, and get back to farming your mini plot of land. Kicking this project off, I'm tackling something I've never attempted. A fully 3D printed drivetrain that uses a single motor to transmit power to both the front and rear axles. In past projects like the semi-truck and wheel loader, I avoided this, favoring the easier assembly of simply loading the motor in next to the axle and then meshing them together with a spur gear. The primary reason for this change in approach on the tractor is my desire to create a 3D printed high-low transmission, and what better model to try it out on than a tractor. This system will let me drive around quickly and high, but when I need to pull a trailer, climb a hill, or get through dense mud and grass, I can drop it into low for maximum torque. Also, if you're wondering how this tractor became the next project, well, it's simply because you guys literally commented hundreds of times asking for it to happen. And because of that, I just want to say thank you for the overwhelming engagement and support. The community behind all of these RC 3D printed projects is awesome. Now don't worry, I wouldn't be starting down this path if I hadn't already figured out a way to make it easy for all of you at home to print and assemble. The motor I'll be using for the tractor is the same style used in both the dozer and the wheel loader, and its size will be the main constraint for this project. Based on its location and the current assembly, it will likely sit beneath the tractor's cab. Another big change on this model that has been consistent for the last 3 years is replacing the truss head screws with standard M3 hardware. I've done this for a couple of reasons, but the primary one is that the old truss head design, while great for biting into plastic, would often shear off if over tightened, and trying to remove the sheared off bit was a huge pain, almost always resulting in having to 3D print a new part. The M3 hardware is simply magnitude stronger. Self-tapping screws like bamboos would be a good option, but they are super expensive compared to generic M3 hardware, so that's what I'll be rocking. To transmit the power from the motor to the wheels, I first designed a housing to hold 2 bevel gears, 1 input gear from the motor, and 1 output gear feeding the wheels. I considered adding a differential, but I prioritized ease of assembly, and a differential would introduce a significant complexity problem. With a differential, any wheel that slips on a loose surface will consume all the power, versus a locked axle where the other wheel will grip and continue helping the vehicle forward. The axle is mounted to the housing with 2 bearings, and the cover piece is pressure fitted over the top and secured with 2 screws. In between the front and rear axles is the high-low transmission. While I explored a few different approaches, by far the simplest method involves equipping the motor's pinion gear with 2 gears, 1 large and 1 small. On the main drive shaft, I positioned a sliding gear cluster with the corresponding small and large gears that can be moved along the drive shaft by servo. When the cluster slides forward, it meshes the motor's large gear with the drive shaft's small gear for the high speed output. When it slides towards the rear, it meshes into the low speed configuration. Since this was all theoretical, instead of just hoping for the best, I hooked up the motor to my power bench and tried shifting the gears manually. I'm only running it at 3 volts here versus the full 12 volts, which gives a good idea on the current system efficiency. Very little power is lost throughout the gear train. Manually slotting the gears back and forth definitely revealed some of the friction that prevents a smooth shift, but I'm confident that chamfering the edges will allow them to mesh together much easier, as well as providing a couple other changes. Crucially, the overall proof of concept works. This model also features my second set of truly functional U-joints, and no, I am definitely not counting the U-joints that were in the crane. Those were just... I specifically wanted to ensure the wheels could turn really sharp without the U-joints binding up, which required a couple of iterations and carving out some extra material, but the final result is quite smooth and definitely strong enough. A tiny unremoved piece of support material from the housing created significant friction. This serves as an important builder's note: diligently remove all excess support material from the gearboxes and gears. The 500 RPM motor, a significantly faster version of the Dozer's 100 RPM motor, makes this tractor noticeably quicker, as you can see in this demo. Note that this assembly is currently unsupported by the main frame, which is causing this whole model vibration. Although the lack of frame support contributed to the failure of the main drive shaft connection point, I revised the design to include a solid sleeve that securely couples the two drive shaft sides. I went with a classic look for the tractor using this green silk PLA, which printed beautifully, with the exception of the front mount piece that failed to print at all. Without the cab, the tractor has a distinct retro aesthetic, but with the cab, it appears much more modern. The only body piece that was a complete design flop was the rear battery cover. I must admit, I did a poor job designing it, as any bump in the road and this thing is for sure falling right off.
Wow, this is garbage.
To add more contrast to the model, I added intake and exhaust stacks, but unfortunately the screws holding them in place come in direct contact with the circuit board holder, so that will need to be reworked. The front wheel arches that hang over the front tires first mount to the brackets and then to the steering knuckle itself so that everything moves together. The PCBs for this project are the most compact I've made so far, primarily because the space under the hood is the only feasible area to house it, and because of that, it needs to be small. For comparison, here it is next to the semi-truck PCB. This gets populated with the headers for the ESP32, H-bridges, and a buck converter, along with a fuse holder and terminal blocks for the wiring, making for a relatively compact assembly. I did, however, let the magic smoke out of this buck converter because I didn't design the header correctly for it. So I'll have to reorder an updated design. At this point, I was so eager to try driving it around via remote control that I didn't even wait for the completed frame to finish printing. I just strapped the electronics to the motor and the battery to the electronics, but before I can actually rip this around, I need to upload the code, which was pretty easy as I was able to use a modified Dozer script to get it up and running. Shifting from first to second on my table was a surreal experience because the mechanism worked perfectly. Though it was much too fast for such a small space. I almost wish I had a third, even lower gear that I could shift to, but that would require yet another transmission redesign. So I'll tell you what, if this video gets 15,000 likes, I'll make a modified transmission that you can swap in that has 3 gears instead of 2. That aside, I quickly moved it to the floor to get a real idea on its handling and speed. With the frame mounted, it won't be able to tip over like this because the front axle will have hard stops, preventing the infinite rotation that currently allows it to just flop over onto its side. The center of gravity will also be much lower. Placing it on the table made me realize why tractors are designed the way they are. The massive rear tires with their large paddles allow it to push through almost any terrain, such as these beans. However, it did struggle climbing the dirt hill, as the TPU tires are just a bit too slick for a controlled ascent. Despite falling off the table and breaking multiple critical joints, it still managed to move, albeit in a somewhat depressing way. But if this isn't the perfect example on why you should 3D print stuff, then I don't know what is. Because if this was some off-the-shelf model, well, it's safe to say this thing would be absolutely done for. But with this, you can simply print 30 minutes worth of parts, reassemble it, and you're back off to the races. This time though, I did actually put the frame, cab, and accessories on. To power this model, I've got 3 16340 Phoenix batteries that get neatly tucked away in the rear body / frame, which the holder itself is just part of the frame, and then I add these cheap battery contacts onto that. I did fail to create a path for the wire to run, but nothing a drill can't temporarily fix until I modify the actual design. Overall, I think the tractor is looking really good. It has a slightly aggressive look I like, while also keeping a bit of a cartoony feel. I know I said it before, but I'll say it again, this thing absolutely scoots on a 500 RPM motor, and it also does wheelies. But if you know how these projects go, you know I had to iterate and modify each piece at least another time, which is why I've got a whole new round of parts printed out and ready to be swapped out. But I'll save you that tedious process, as not much has changed aesthetically. One way to really show off the high-low system is climbing over obstacles. Now in high, you can see it just barely doesn't have enough power to make it over these foam pads, but in low, absolutely no problem. I spent a couple days driving this around outside in my backyard, getting a feel for how it does in grass and dirt, and I can safely say it does really well. Again, I think it's a testament to just how tractors are designed, with the massive paddle tires in the rear and high clearance. For instance, it can plow through this grass that's just as tall as it is, no problem. I also had the family pet give it a vibe check, and well, I'm not sure she approved, but I'm also not sure she disapproved. With the tractor itself in good working order, I think it's time to talk about tractor attachments. I spent a lot of time going back and forth on this, as I personally really enjoy making cool mechanisms that allow for hands-free hitching and power transfer, like the semi-truck hitching mechanism or the wheel loader's quick coupler. Right out of the gate, this was the path I pursued, with the attachment assembly itself having a servo to move it up and down, but then for a way to couple to attachments hands-free instead of having a whole other servo to lock it in place, I created this little switch mechanism that just operates off the already powered up and down motion. The idea is the bottom 3/4 range of motion can be used to raise and lower the attachment, but then when you want to disengage and engage the top lock, you can bring the coupler up past this little TPU piece, which catches on the flap, allowing you to lock or release the attachment. At first, it was pretty rough, but after a couple days, I did get it working better. Keyword is better. It never worked great, more just all right. If the stars aligned and you masterfully reversed it into just the right spot and the attachment didn't tip over on contact, you could maybe, just maybe, get it to lock in. And maybe this mechanism is worth pursuing. But I had another mission in mind, which was to also have a PTO point. And for those who don't know, PTO stands for power takeoff, which essentially just lets you take power from the tractor and transmit it into the attachment. Now there's both shaft driven PTO and hydraulic PTO systems. I gravitated towards the shaft PTO as that seemed easier than trying to set up some kind of power transfer, but after spending almost a week on this one coupling style, I realized there would be no actual way to get this little motor to engage with the attachment. At least not easily or reliably. So with that, I decided to rethink this entire coupling situation. Over the last couple months, I've had requests for a somewhat simpler model, like the OG Mini Skiddy, which jump-started this YouTube channel. And while the tractor itself is more complex, I've decided to apply that request to the coupling mechanism. Instead of having it lock and unlock via this TPU switch, I now just made it so that you can by hand lock it into place. Now, not only is this infinitely easier to build and use, it's also way more usable, as before the attachment would just fall out of the coupler due to how loose I had to have the tolerances in order for it to couple. Now though, you can press it into place so that it's rock solid. Addressing the question of PTO, now that attachments have to be loaded by hand anyway, I just routed this servo extension cable out to the back, where you can then just plug whatever servo is powering the attachment directly in, just like you were connecting hydraulic hoses in real life. For instance, this blade attachment, which began life with having to change the blade angle by hand, now has a servo in place that lets you change the blade angle on the fly. In today's experiment, I'm testing a new filament for tires. I've seen this material featured across YouTube, but it was a Maker's Muse video showing it used for BattleBot tires that really sold me on it. This TPU actively foams during printing, creating micro air pockets that make the tire squishy and provide traction rather than feeling like slick plastic. To be clear, this is not a sponsored product. I used a basic P1S with the official Sierra Tech print profiles, and it printed at a respectable speed without any issues. However, the requirement to keep the filament dry is absolute. While the first print was perfect, the second print, when the filament had been left out for about 12 hours, left behind permanent residue on the build plate. Always use a dryer box with this material. The hand squish test exceeded expectations as it is genuinely flexible. To see if it delivers where it counts, I set up a tractor test using a mini jack, a piece of plywood, and my phone to measure incline. On the stock TPU tires, it did 20 degrees, no problem. And honestly managed to still climb slowly, though haphazardly, all the way up to 33 degrees, which is way more than I thought it would do initially. Swapping in the TPU air tires, the difference was immediately noticeable. At 33 degrees, I was no longer fighting for my life to keep it on track, but rather it just tractored right up it.
Oh yeah.
At 40 degrees, I still had great traction, but was definitely fighting the limits on top heaviness. "42 degrees proved to be too much, so I can safely say that from a very shaky 30 degrees on the TPU to a steady 40 degrees on the TPU Air, this stuff is 100% worth purchasing to upgrade the tires on any of your models. And this was just on a flat sheet of plywood. The benefits increase by a degree of magnitude on rough terrain as the foam molds around any texture in the surface, helping to pull itself along. I've got a slightly outlandish idea, and it involves all of that dirt. What I'm thinking is, if this video convinces enough of you to build this RC tractor, not only will I add a third gear to the transmission, but I'll also add an arm and bucket combo to the front. Then, to demonstrate its capability, I'll build a dedicated miniature garden where the only thing allowed to plant, water, or harvest whatever's grown will be these RC tractors. No human intervention. So if that sounds cool to you, think about maybe 3D printing and building one of these for yourself. Instead of taking this model outside like I normally would, I decided to bring the outside inside via some dirt, which I spread out across my table. And if you're wondering, yes, my whole room now smells like a garden. Before deploying the tractor, I first wanted to see if I could fit it on the drop deck trailer, which it did, no problem. In fact, if you really want to, you're able to fit 3 of them in a row on the standard length drop deck. These last 3 months, I've purely been working on this tractor, so I haven't had much time to mess around with the semi-truck, and well, I really missed driving this thing. It's definitely still one of my favorite creations, and it towed these 3 tractors like it was nothing. Driving around on soil for the first time, I can definitely see that it turns a bit wider now as the axles are sliding a little bit on the loose soil. I went with the ripper attachment first, as to me, it's just one of the most classic tractor attachments. It pulls it through this loose dirt no problem, and actually even leaves nice little rows that, dare I say, you could definitely plant some beans in.
Nice.
Swapping out the ripper attachment, I went for the blade. Now this one definitely takes a bit more finesse, as if you dig it in too deep, it'll anchor the entire tractor down. Where this really shines though is if you have a thin top layer of material to remove, or maybe just flatten, you can use this to really fine grade it. As a whole, my favorite part about this tractor so far is just the raw climbing power and the grip it has. I had a ton of fun designing the 4-wheel drive drivetrain and high-low transmission. It's one of those things where I consistently get a
wow, that's That's kind of cool.
when I'm showing someone the tractor and they see it shift from high to low. I look forward to adding some cool attachments for it in the near future, but for now, I've got a massive pile of dirt I need to start cleaning up. So if you'd like to 3D print and build your own RC tractor, consider checking out the workshop on my website, professorboots.com. By joining, you'll have access to step-by-step guides on all of these projects, such as the semi-truck, wheel loader, and of course, this tractor. They cover everything from soldering the electronics and coding to assembling the model with your own 3D printed parts. This is also just how all of these projects are funded, so a huge thank you to everyone who supports and builds them. Now, it's of course time to talk about what the next project might be, so leave a comment down below with whatever piece of equipment you'd like to see next. For instance, a fire truck, road grader, compactor, etc. You name it, and I'll do my best to build it. Whatever gets the most comments and support will be the next project. With that, thank you all so much for watching, and I'll see you here soon with another project.